Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. Hello Raghav. I'm Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for the last 11 years. So today we are going to start differential equations, but before we begin, let me tell you about this Unacademy subscription. Just a moment, let me check. My audio. So today we'll continue differential equations. All right. Good. So if you're preparing for IIT-JEE, then you can have two types of subscriptions on Academy. One is Plus subscription, and there is Iconic subscription. Okay. So let me tell you about the Plus subscription first of all. If you get Plus subscription, then you get unlimited access on the platform. You can watch live sessions of all the educators, and then you can follow educators of your choice. It is completely up to you. You have all the freedom, and all the tests and live tests and quizzes will also be accessible to you. And all the courses which I was talking about are well structured. That means everything is pre-planned. So you can see the schedule of educators and all the upcoming lectures with time and date and topic name, everything. Okay. So these are the features you get in Plus subscription. And it's in simple word, if I say, then it is unlimited access you're getting on the platform. Okay. By applying by getting Plus subscription. All right. Now these are the subscription charges. You can subscribe for 1 month, 3 months, 6 months, 12 and 24 months. 12 and 24 months are the best packages if you compare price, because average price per month is low in these two, so you can go for 12 and 24 months, and it is 38,500 for 12 months and 56,000 for 24 months. And yes, of course, you'll get 10% discounts in that, applying if you apply referral code JEET1. Okay. Now the second is Iconic subscription. So in Iconic subscription, you get a personal coach. Apart from all the benefits of Plus, personal coach means uh, an expert will guide you throughout your preparation for top exams. Your test analysis will be done in a personalized manner. Your personalized feedback will be given to you to improve your time management and exam approach. And your study planner will be customized, and bi-weekly reviews will be given to you, highlighting your progress. Okay, so this is Iconic subscription. Then in Iconic subscription, 12-month subscription is of 56,000, right? And 2 years subscription is of 86,000. And of course, you'll get 10% discount in these two, applying the same referral code JEET1. Okay, so you can apply that referral code. So these are the two subscriptions you can have on Academy. Now, yeah, now this is the information about Unacademy's combat second contest Friday JEE on November 22. Okay, that means tomorrow. Timing is 11 a.m. For class 11th, class 11, class 12th, and dropouts. It is from 11 to 11:45 a.m. Physics, chemistry, maths, and 7 questions in each round. Okay, so enroll for this second contest for IIT-JEE on November 22nd. Okay, date and time I have told you, so you can enroll it for this Unacademy's combat. Alright, Raghav, I can see it. Okay, I can see it. I'm just starting. Okay. How are you? Just a moment. How are you, Raghav? Yeah, one more information. After downloading this Unacademy's learning app, you can start your preparation. You can start attending special classes without having any subscription. So just download this, make your account, and start special classes every day. A lot of educators are taking special classes, so you can attend those classes. All right. All right. Okay. So chalo, let's start differential equations. So see, what is differential equation? The differential equation we call if an equation has dependent variable, independent variable, differential coefficients, and constant is called a differential equation. Okay, देखो मैंने क्या लिखा है, I'll explain this. देखो जब हम for what is this dependent and independent variable, when we write y is equal to fx, x is called independent variable, and y is called dependent variable. Okay, and differential coefficient means like dy by dx, d2y by dx2, by dx3. These terms are called differential coefficients. Okay, differential coefficients or derivatives, you can say. Okay, of derivatives of any order. Derivatives of dependent variable with respect to independent variable, I have written here, and constant, you know. Okay, so any equation which has these terms like dy by dx plus 2x d2y dx2 is equal to 4 ln y. Okay, like this. You can see this equation has differential coefficients, independent variable, dependent variable, and constants 2 and 4, right? So this is called a differential equation. Now what it should not have, it should not have any other variable. Okay, like parameter. If I put a parameter a in this and I say a is a variable, then that will violate the rule. So I hope now it is okay. It should not have any other variable. Like you can't put lambda, and lambda is not a constant. All right. Now there are two terms. One is degree and second is order of a differential equation. So what is degree and order? Let me explain. Degree. Okay, the order is simple. First, let's finish order. So what is order? Yeah, you'll have to eliminate it. Order is, so order of a differential equation, is the order of highest order derivative present in the equation. मतलब जो highest order differential equation, highest order derivative present होगा, order of that is called order of the differential equation. Like if I write dy by d2y upon dx2 plus dy by dx whole cube into x is equal to y square. What is the order of this? Tell me order. Tell me order, Raghav. Two, very good. So order is 2. Yes, you can see order is 2. Is this 3? Do not get confused with this 3. This is not the order of dy by dx. Order of this term is 1, right? This power is related to degree, okay? So it won't affect. You can see the highest order derivative in this equation is d2y upon dx2. So its order is 2. So answer is 2, okay? Yes, that was the question. Very good. So now you understood the derivative, huh? Let me tell you the degree. हाँ कमेंट आने में थोड़ा oh, what am I writing यार So degree of a differential equation is defined. First of all, it might happen that degree is not defined, okay? Degree of a differential equation is defined if equation can be expressed in a polynomial form. Polynomial in differential coefficients. मतलब जो dy polynomial means what? When you write polynomial in x, that means powers of x should be positive integers, right? So when you say it is a polynomial in differential coefficients, so all the powers of differential coefficients should be positive integers, right? It should not be under root of dy by dx in the equation. Okay, if it is there, then you should be able to remove it. Then you can define degree. Okay, if you can't remove dy by dx, then degree will not be defined. Sorry, under root. हाँ लास्ट में डिग्री 3 था. Okay, so after expressing the equation in polynomial form, degree of the equation is the highest power of highest order derivative present in the equation. Okay, now let's see. For example, dy by dx whole raised to 3 plus d2y upon dx2 into x square whole raised to 4 plus d3y upon dx3 whole raised to 2 plus 5 ln y is equal to 0. Okay, so answer the degree of this. Answer the degree of this. Oh, now you did a mistake, huh? You got caught. This guy Raghav. See, the problem is मैंने बोला था order if they see this is a polynomial form, ठीक है, no problem in that. But the degree of the equation is highest power of highest order derivative. So highest order derivative is 3. This is the highest order derivative. And its degree is 2. Its power is 2. So answer is 2. Okay. Do not get confused with this 4 or 3. Okay. Just look at highest derivative. Samjha? So I'll give you some examples. You tell me the degree. Under root of. Okay, so answer these questions and then we are done. Okay, example 1, example 2, example 3, example 4. Okay, we have 4 examples. Answer number wise. What is the answer of first one? What? 2, 3 होगा. 3 होगा. Okay, in example 1, your answer is 3. Huh? Okay. So see, this is not a polynomial form, but we can express this in polynomial form by squaring it. So if we square it, we'll get 1 plus d2y upon dx2 whole raised to 3 and is equal to 1 plus dy by dx into y whole square. Okay. Now it is in polynomial form. So after expressing it in polynomial form, now what is the degree? Degree is 3. Okay. So degree of this term, degree is 3. So right. Now the second example, you are saying degree C 3 first का. Second का answer क्या है? What is the answer of the second one? Two. Are you sure? I'll give you one more chance. Recheck. Oh, sorry. That I'll do correction. Okay. d3y upon dx3. That was the correction. So the answer is 2. Okay, finally you're giving me answer 2. Okay. See, to remove this surds, this is cube root and this is square root, you'll have to put power. How much power you'll have to put? You have to put 6 power, right? Because this is square root and this is cube root. So if you put 6 power 6 here and power 6 here, it is going to be 1 plus d3y upon dx3, the whole square, and again square of this, right, is equal to 1 plus dy by dx whole cube, right? So now you can see if you expand it, this power is going to be 4, right? 2 into 2, 4. So you'll get a term d3y upon dx3 whole power 4. So degree is 4. Are you understanding it? Degree is 4. Degree is 4. Did you get it, Raghav? What do you mean दो बार दो लिखा? What is that? I meant 2 into 2 इसलिए दो बार. What? No. You're trying to make up, huh? Now what is the degree of the third one? Degree of third one is, can you express this in polynomial form? So this is y triple dash plus y double dash square is equal to, just remove ln, so you can write e raised to 1 plus y. Okay, so yes, this is polynomial in differential coefficients. Okay, exponential function might be there, some function of x and y. So degree is 2 in this case. Okay, power of second order, sorry, degree is 1, not 2, degree is 1. Third order derivative, so degree of this is 1. Got it? Degree of this is 1. Okay, now answer the last one. Okay, I am waiting for last answer. Example 4. Which question are you telling me to? 1 plus. Which question are you asking me to see? Oh, okay. Sorry. Yeah. The third example, huh? Okay. Yes. I wrongly written y triple dash. It is y dash. Okay, you're right. It is y dash to the power 3. Okay. Okay, so degree is 2. Yes, degree is 2. You're right. Okay. Okay, done. I just copied y triple dash. Okay. It was y dash cube. So degree is 2. Yes, correct. Now what is the answer of the fourth one? Oh, the last one, again you are doing a mistake. You are ignoring a very important point. Degree is defined when? No, not differentiate. You can't differentiate this, okay? We just can do squaring and something. You can remove one function, but you can't differentiate it, okay? So if you remove ln, you can remove ln. How do you remove ln? If you remove ln, then it will be exponential function e raised to y double dash plus 2. So you can see again it is not a polynomial form because y double dash is the exponent of e. Okay. So in this case you can't remove ln or exponent function. You can't bring this in polynomial form. This can't be brought in polynomial form. So degree of this equation is not defined. Okay. See, whenever it was a square root, cube root, we did squaring or cubing or power 6, right? In the third example, we removed ln because right hand side there was no differential coefficients. It was e raised to 1 plus y. But if it would have been 1 plus y dash, then also degree in the 3 is also not defined. Are you understanding? Are you getting it, Raghav? So that means we can't express the fourth equation in polynomial form. So hence degree of this equation is not defined. Hi Parshva. So it's not necessary that you always define a degree, or you can always define a degree. You might not be able to define the degree of the differential equation. Okay. Order is always defined, but degree might not be. Okay. If we can't express the equation in polynomial form, then degree will not be defined. So just be careful with the degree. Okay. Have you got it? Huh? Shall we move? So now we are going to do. First, we'll learn formation of differential equation. It's a small part. And then we will start solution of differential equation. So see how to form. Formation of a differential equation. See, differential equation, whenever you have a differential equation, it is differential equation of a family of curves. Family means a group of curves. Like you write x square plus y square is equal to a square. A is a parameter. So it's a family of circles whose center is at origin, right? This is family of circles centered at origin, right? So all this family will have one differential equation, okay? For all values of a, you will have only one differential equation. So whenever you have a differential equation, it is differential equation of a family of curves, okay? Is this point okay? Is this point okay? And how do you get a family? So in any equation, when you have a parameter and when that parameter varies, okay, then you get a lot of curves which have something in common, like in this a is varying, right? A is a parameter. So when a varies, that means radius is varying, but center is constant, center is fixed, right? So it is giving a family which have center common, right? It is giving family of circles in which center is common, right? So whenever in any equation you have a parameter, then it becomes a family of curves, right? And like you write y square is equal to 4 ax, and you write a is a parameter. This is family of parabolas, right? This is family of parabolas. Even you can write x square upon a square plus y square upon b square is equal to 1. In this you can say a and b both are parameters, not constants, okay? If a and b both are parameters, there's a difference in parameter and constant. Parameters means it can take any value, and constant means it has a fixed value. So in this equation you can say a and b are constant, then it's a fixed curve. But when you say a and b belong to real numbers, that means they are parameters. They can take any value. So this is a variable ellipse now. Variable ellipse, but its center is at origin, right? So all these ellipses, x square upon a square plus y square upon b square, they have center at origin, but their major and minor axes are not fixed, okay? They are varying. So this family of curves has two parameters, okay? This family of curves has two parameters. This is a family of ellipses having center at origin. and major axis as x-axis and minor axis as y-axis. Okay, so these many things are common in this family, but major length of major axis and length of minor axis are not fixed, they are varying. Have you understood this concept, family of curves? So how do you get a family of curves? In any equation, when you have a parameter, one parameter, two parameters, might have three parameters, four parameters here. So it represents a family of curves. Okay. I hope you have got it. I hope you have got this point. Rago, just answer it. Huh? Okay. So now, so one family of curves will have one differential equation. Okay. One family of curves will have one differential equation. So differential equation will be, one differential equation will be, in the other way you can say, one differential equation will represent all the curves of a family. Like in this equation, x square plus y square is equal to a square will have one differential equation. That differential equation will be for x square plus y square is equal to 4 also. And the same differential equation will be for x square plus y square is equal to 1 also. Okay. Okay. So I hope this point makes sense. Now suppose you have a family of curves, differential equation of a family of curves, family of curve f of x, y, c1, c2, c3 and so on cn, okay, is equal to 0. I'm saying this c1, c2, c3 and cn are parameters. Okay, it might have n parameters, n minus 1 parameters, 2 parameters, 3 parameters. So how do you get a family? I mean, how many times you need to differentiate it? Like in this equation, see, if I say, what you need to do is you start differentiating this curve to make the differential equation, and then you eliminate the parameter. If it has only one parameter, that means you need to eliminate that parameter, because we know that in differential equation there should not be any parameter, right? So like if I try to make the differential equation for this curve circle, now I start differentiating it. This is 2x plus 2y dy by dx is equal to 0. Oh, so parameter is eliminated automatically, right? We haven't done anything for that. We just differentiated and parameter is eliminated. This is the simplest case. This is the simplest case, okay? Okay, but can we differentiate it further? Because yes, of course we can differentiate it further, and if we differentiate it further, it will be of second order. This is first order differential equation, right? First order. You can see this is first order differential equation, but if we differentiate it further, then that will be second order. So if I differentiate, oh, sorry. Okay. I'll write it again. X square plus y square is equal to a square. If I differentiate it, it is going to be 2x plus 2y dy by dx, okay, is equal to 0. A belongs to a real number. See, so I got this, x plus y dy by dx is equal to 0. But is it the differential equation because we have eliminated the parameter? Or if we further differentiate it, then it is y plus 1 plus y dy by dx plus y y dash into y d2y upon, sorry, 1 minute. This was d2y upon dx2. If I further differentiate it, it is going to be like this. Y dash whole square is equal to 0. So this is equation 1 and this is equation 2. Now which one is the differential equation of circle, family of circles? X square plus y square is equal to a square. The first equation or the second one? And why? Whatever your answer is, give me with logic. Because you can keep differentiating it, you'll get another equation. But where to stop? That is an important point. Second, okay. You are saying that the second equation I've got. See, constant should be, no, it's not necessary that constant should be present, okay. No. That is not. Constant is there. Constant is always there. 1 is always there. Coefficient of x is 1, okay? It should not be visible like in second equation. See, you need to differentiate a equation the number of times depending on the parameters. So if it has only one parameter, then its order is going to be 1. Order of the differential equation is going to be 1. So order of a differential equation depends on the number of parameters present in the equation of the curve, family of curves, okay? Let me write it here. Order of differential equation of a family of curves is equal to number of parameters. Number of parameters involved, number of distinct parameters, okay? Number of distinct parameters involved in the equation of family of curves. So now you can see in this equation, it has only one parameter, okay? It has only one parameter, so its order of differential equation should be 1. That means you need to differentiate it 1, okay? Once. So this, and after differentiating it, you need to eliminate that parameter. So that parameter is already eliminated. So this is, first one is the differential equation. You can't differentiate it twice. If you're differentiating it twice, now see, and you are saying that second is the differential equation. Hey, are you understanding this, Raghav? See, if second is the differential equation and we start solving it, then we'll have to integrate it twice. So when you integrate it twice, okay, because it is second order differential equation, you'll get two parameters, because when you integrate, you get a integrating constant, right? Integrating constant, which is basically arbitrary constant or parameter. So when you integrate it twice, you'll get two parameters. So a second order differential equation will give you two parameters. Like if I give you one example, like this, d2 y upon dx2 is equal to 1, say, okay, 1. It's a simple equation we can integrate. So if I integrate it, we'll get dy by dx is equal to x plus c, right? And further, if we integrate it, we'll get y is equal to x square by 2 plus cx plus c dash. So have you got it? If you have second degree equation, you'll get two parameters by solving it. So family of curves of second order will have two parameters, right? Similarly, if you have third order differential equation and if you start solving it to get the family of curves, then family of curves you get will have three parameters in its equation. So while solving it, if family of curves has three parameters, that means you need to differentiate it thrice. That means its degree, its order, its differential equation will be of third order. Okay. So I hope you are understanding it. Okay. So I was giving you this example. Let's suppose f of x, y, c1, c2, c3, and so on, cn. Okay, are parameters in this equation. C1, C2, C3 up to Cn are n distinct parameters. Now this distinct is also important. I'll tell you later. Okay, I'll tell you after this. Distinct parameters. Then what we will do? We will immediately, now we know that this equation has n parameters. So we will immediately start differentiating it. And how many times we will differentiate it? We'll differentiate it n times. Okay. So first we'll differentiate it f dash x, y, c1, c2, and so on up to cn is equal to 0. One equation. Then f double dash x, y, and so on, cn is equal to 0. Second equation. And so on f nth derivative. Okay. Nth times. So x, y, and so on up to cn. This is nth equation. Okay. And this original equation is n plus 1th equation. So in coordinate geometry, you must have, while finding the locus of an equation, you must have heard this, that when you have one parameter, then you need two equations to eliminate it. When you have two parameters, you need three equations to eliminate it. When you have three parameters, then you need four equations to eliminate three parameters. Similarly, when you have n parameters, you need n plus one equations to eliminate n parameters. So now you can see you have got n plus one equations, because you had n parameters. So one equation was given, equation of family of curves, and n equations you have got by differentiating this. Okay, by differentiating this. So you've got now n plus one equations. So using these n plus one equations, now you can eliminate all the parameters. And after eliminating all the parameters, you will get the differential equation, and order of that is going to be nth order. Yeah, like twice in ellipse. Now here we have got it, huh? Got it now? Now I'll give you curves. Okay, these questions are also important in exams. They give you a family of curves and they ask what will be the order of differential equation of this family. Okay, so what you do in that case, you just figure out the number of distinct parameters. You don't differentiate it. You don't form the equation. You just look at the distinct parameters involved in the equation. And by looking at that, you answer that, oh, this equation has two parameters. That means the differential equation is going to be of second order. Okay. So that is the question we are doing now. Find the order of differential equation of the following family of curves. The first one, the second one, whatever a, b, c, x, y, z, I am right. Whatever a, b, c, m, x, other than x, y, any letter I use, that is the parameter. Okay, I'm just saying this. These are not constants. All right, now let's start. What is the order of the differential equation? You don't need to form the differential equation. Okay, you just tell me the order now. What is the order of differential equation of this curve? Two, right? Good, correct. Second, Okay, correct. Third. No, this is wrong. Third is wrong. Third is not 3. See, these are not two distinct parameters. You can club these two, and if you can club these two, and you can write this a new parameter C. Okay, like C can be written as C1 plus C2 plus C3 plus C4, but these are not distinct. You can club these parameters. You can write one parameter in place of these two. So effectively, you have two parameters in this equation. Okay. Effectively, you have only two parameters. If you can club two parameters, then it will make one parameter only. So these are not two distinct parameters. In this equation, you have only two, M and C. Now this M and C can't be clubbed. So it's an equation of two, second degree. Now you do the third and fourth and fifth again. It's not always like that. The parameters you are seeing, it will be like these are all distinct parameters. You might club some parameters and write one parameter instead of two, or maybe three. Fourth answer is 3. Fourth answer will, are you okay? The answer is 3, still 3. Okay, but let me give you this idea. This can be written as C1 e raised to C3 into e raised to C2x. Okay, now this whole thing is a new parameter C. So you can write this C into e raised to C2x. Now you can see it has two distinct parameters. Two distinct parameters. So its order is going to be 2. Are you understanding it? Still your answer for last one is wrong, okay? Now I think you must be having an idea. Try to find the order of the last one again. Are you understanding this? What am I doing? No, it's not 5. It's less. You're not clubbing the parameters effectively. See, how can you reduce the parameters? That is your task. They give questions like this, the question number 6, and they ask what is the order of, okay? So these are the questions. You give some complex equation like this, and then you need to club parameters. See, it is, see, first of all, we can write C1 e raised to C3 and e raised to C2x. You can't remove this C2. So effectively, now you can see this is one parameter, plus. Now you can write C4, ln of C5x can be written as ln of x plus ln of C5, okay? And plus C6. Finally, this is one parameter k e raised to C2x plus this is C4 ln x, and this whole thing, this into this, and this C4 will be multiplied to this, can be written as, let me write k1, and this is k2, okay? So finally, now you see how many parameters you can see. Now you can't club any two. So this k1, c2, c4, and k4. So it has 4 parameters. So fourth order, okay? Order is 4. 4 is the answer. Have you understood? 3 kaise? How are you getting 3? Tell me how to reduce it further. Its answer is 4. So answer is 4. 4. Okay. Now let's do some questions in which you need to form. Now we are forming the differential equation. Form the differential equation of the following family of curves. So first curve is y is equal to a e raised to x plus b e raised to minus x. Okay, this is a very simple curve. Solve it. Solve it and tell me. And this one will do. Our ellipse. Okay, so these two questions we are going to do for formation of differential equation. So both curves are going to be of second order, right? Let me give you one example. If you have y is equal to mx, it has one parameter, so order should be 1. If you differentiate it, dy by dx is going to be m. Now you have these two equations, 1 and 2, to eliminate m. So to eliminate m, just put m from second equation in the first one, or maybe m from first to second. So you'll get dy by dx. In place of m, you can write y upon x. Okay, so this is the answer. In this way, you can eliminate m using these two equations. This is the differential equation. Okay, Let me do it then. Well, differentiate it twice. We can see that it has two parameters. So y dash immediately differentiated, a e raised to x minus b e raised to minus x, right? Again you differentiate. So y double dash is going to be a e raised to x plus b e raised to minus x. Now eliminate a and b. So to eliminate a and b, now you see this whole expression can be replaced by y. So you can write y double dash is equal to y. This is a standard equation basically. Whenever you have y double dash is equal to y, you can take y is equal to a e raised to x plus b e raised to x. Okay, so this is the differential equation. Got it? Now let's do the second one. Understood? Now in second one, see in this we haven't done much efforts to eliminate a and b. It was easily done, right? So yeah, second equation was not even used, right? It's all right. But third will always be used. Third equation will always be used. Last one. Okay, because order is going to be defined from that equation only. So if I differentiate it, there is going to be 2x upon a square plus 2y upon b square dy by dx is going to be 0. And further differentiated because we know that the order is 2. So first eliminate this 2 and then differentiate. So we'll get 1 upon a square plus y upon b squared y double dash plus 1 upon b square y dash square is equal to 0. Now eliminate 1 upon a square and 1 upon e square. So how do you find? You can solve this first and second equation to get 1 upon b a square and 1 upon b square. Multiply this second equation by, see, now you need some calculation. If multiply this equation by x, if you multiply, you'll get this x square upon a square plus xy upon b square into y dash is equal to 0. I'm writing this equation as fourth equation. Subtract this fourth and first. So you'll get this 1 upon b square y square minus xy y dash is equal to 1. See this. And from this you'll get y square, right? B square. 1 upon b square you are getting as 1 upon y square minus x y dash. Okay. So similarly you'll get a square also. And once you get a square and b square, put in this equation. All right. Are you understanding it? So in this way you can eliminate. It's like the elimination of parameters you do in coordinate geometry while finding the locus. Okay. All right. So now we'll start solving differential equations from tomorrow. Okay. So this was the introduction, formation of this, and then solution of differential equations will start tomorrow. Yeah, I'm ending it. All right. Okay then. Okay, Raghav. Thank you very much. Okay. Take care.